Okay, I'm going to go over properties of logarithms. As stated here, we have the first one called the product property. And since logs are inverses of exponentials, notice that the properties are very, very similar to the laws of exponents. So look at the first one, the product property. A product in math means multiplication. So if you look at the exponential example on the left, if we have some number raised to x times that same base raised to y, we could simplify that by writing it as one base of b raised to the x plus y. So notice logarithms have that same property. If I have log given a base of m times n, I can expand that logarithm as long as they are the same base by taking log of the first plus log of the second. So product means multiplication, and multiplication is repetitive addition. So add the two logs. Quotient property, again on the left side, look at our exponential logs, or exponential rules, laws of exponential equations. If you have a base raised to x divided by a base raised to y, well, division is just repetitive subtraction, so we can subtract those exponents. So quotient property of logarithms states the same thing. If I'm taking log of a certain base of m divided by n, well, then I can expand that into two logarithms by taking log of the numerator m minus log of the denominator n. Power property, if we look on the left on exponential examples, b to the x times, or raise, all of that raised to the y, equals b to the xy. So in logarithms, we have what's called the power property, which states if I'm taking log given a base of a number, I can take that exponent and move it into the front. So this is going to be the exponent n times log base b of m. And the last one, I don't really have a name for this one, but if we have log given a base and a base of n, well, since logs and exponentials are inverses of each other, they cancel each other out. So log of a base given the same base, those are going to cancel. We're just left with the exponent n. Okay. So knowing these properties of logarithms is going to help us when we eventually solve exponential equations algebraically. So while we can easily solve them graphically or just by graphing, we're going to need to utilize these if we don't have access to graphing calculator. So let's practice simplifying. So if we have log base 4 of 32 minus log base 4 of 2. Well, here, subtract, if we have subtraction. Subtract means divide in regards to log properties. So we have log base 4 of 32 divided by 2. 32 divided by 2 is 16, so log base 4 of 16. But we're not done because we can rewrite 16 as log base 4, and 16 is actually 4 squared. Well, log of 4, base of 4, those are going to cancel. We're just left with 2. So look at the next one, 6 log x plus 5 log y. So again, if I want to simplify, I want to turn into one log. So the first thing I'm going to do is I'm going to make into exponent. So the 6 in the front, I can put as the exponent. The 5 I can put as the exponent. So we have log base x to the 6th plus log y to the 5th. And next I look at the addition, and addition regarding our log properties means to multiply. So I can take log of x to the 6th times times y to the 5th. And since x and y are not the same base, I can't do anything with those exponents. I am done. So what if we have 2 log 4 of 6 minus log 4 of 9. Well, first thing we can do is make into exponent. So we have log base 4 of 6 squared minus log base 4 of 9. Well, 6 squared is 36. Now we can look and see that subtraction means to divide. So we have log base 4 of 36 divided by 9. 36 divided by 9 is 4. And notice we have log of 4 raised to 4, so both of those are going to cancel.
Yes, Lane. I didn't get you right.
So log of 4 base of 4 is going to cancel. And we're just left with the exponent, which is 1. So again, this really would have an exponent of 1, so our answer is 1. So what if we had log base 4 of 5x plus log base 4 of 3x? Well, again, we have two logs that with addition in the middle. So addition we can condense using multiplication. So log base 4 of 5x times 3x. And what is 5x times 3x? 5x times 3x is 15x squared. And 15 doesn't have any base of 4, so that is simplified. So let's go the other way now. We have simplified. We have made into smaller 1 log. Now let's go the opposite way and let's expand and turn into more logs. So what if we have log base 3 of 250 over 37? So again, we want more logs. Here we have divide. So to divide, we can subtract. So log base 3 of 250 minus log base 3 of 37. And we can't simplify that, so you're done. If we have log base 3 of 9x to the 5th. So if we need to expand, well, first we have multiplication. Well, multiplication is just repetitive addition. So log base 3 of 9 plus log base 3 of x to the 5th. Well, 3 and 9 can be rewritten as a base of 3, so this is the same as 3 squared. And the 5 I can put in the front, so this would be plus 5 log 3 of x. Well, log of 3, base of 3, those are going to cancel. We end up with 2 plus 5 log 3 of x. Okay, so log property is very similar to laws of exponents. Product property, multiplication can expand with addition. Quotient property, division can be expanded with subtraction. And exponent can be moved in front of the log.